Here are two divisibility rules of 7 and why they work. One of the rules is to take the last digit of that number, double it, and subtract that from the number created when we remove the last digit. If that difference is a multiple of 7, then the original number is divisible by 7. And this is an if and only if statement, so the other way is true as well. If this number is divisible by 7, then this difference is a multiple of 7. And this other divisibility rule of 7 was created by Chika Ofili from Nigeria when he was 12 years old. What we do is we take the last digit of that number, multiply it by 5, and add it to the number created when we remove the last digit. If that sum is a multiple of 7, then the original number is a multiple of 7. And this is an if and only if statement as well, so if this number is a multiple of 7, then this sum is a multiple of 7. Now let's prove why these work. I'm going to prove the 4-digit case, but we can see how we can generalize this idea. Say that we have a 4-digit number A, B, C, D. We can rewrite it like this. And I'm going to rewrite 1000A as 700A plus 300A, 100B as 70B plus 30B, and 10C as 7C plus 3C. Now we have this 1D over here. I'm going to rewrite 1D as 7D minus 6D. Because when I do that, I can factor out a 7 from the first 4 terms and a 3 from the last 4 terms. Now, this number is a multiple of 7, so we're good here. 3 is not divisible by 7. So, if this expression, or ABC minus twice d, is a multiple of 7, well, a multiple of 7 plus a multiple of 7 will be a multiple of 7. So that means ABCD will be a multiple of 7 if this expression is a multiple of 7. And the other way is true as well. If this number is a multiple of 7, that forces this expression, or ABC minus twice d, to be a multiple of 7. Now with proving Chika Ofili's test, instead of writing 1d as 7d minus 6d, I'm going to rewrite it as negative 14d plus 15d. And it's a similar argument as before. So if abc plus 5d is a multiple of 7, that forces abcd to be a multiple of 7. And the other way is true as well. If ABCD is a multiple of 7, that forces ABC plus 5D to be a multiple of 7, or else this wouldn't be a multiple of 7. So there you have it, 2 divisibility rules of 7 and why they work. Now, I think that these are elegant. However, practicality-wise, I would rather just divide by 7, to be completely honest, just because I don't know that many multiples of 7 in the higher hundreds or thousands. Now, here's a challenge. What's another way we can rewrite 1D so we have another divisibility rule of 7? Think about it, let me know in the comments, publish it, and remember me when you're famous.